Hi, and welcome to my introduction to inequalities. And I thought I'd just go right in and tell you about what they are. Well, this right here is all this and this and this and this. They're all inequalities. There's four of them. And you can see this means greater than, and with the extra bar right there means greater than or equal to. This is the opposite, means less than, and then if you have the bar again, it's less than or equal to. And so we're going to use these here and we're going to graph them. So this is a review for 7th graders. As this was discussed in 6th grade, when you graph these inequalities, we're talking about x. So x, you often call that as the numbers greater than 4. Well, what numbers are greater than 4? Well, it starts with 5. So I'll, over here on the right of 0 is 5. So 5 is somewhere around there. And if you have either the greater than or the less than, you're going to end up with an open dot. And if you have the greater than or equal to or the less than or equal to, you will have a closed in dot, okay, because that closed in means that includes that number. So when we're talking about graphing, the number is greater than 4. Oh, what I should do is I should actually make this 4, not 5, but 4. So when we're graphing the numbers greater than 4, we start with an open dot over the 4, and we point an arrow in the direction of the numbers that we need. The numbers greater than 4 start at 4 and go to the right. But it does not include 4, right? We could be talking about 4.1, and all those tiny, tiny numbers right just to the right of 4, just not including 4. So when we move down to the numbers, less than -1, then we're talking about -1 is to the left here, somewhere to the left. And I'll place number -1 here. And then it's an open dot over the -1. And the number is less than -1 because, once again, this is the numbers less than -1. We'll point to the left. And so there's that graph there. And finally, for our graph of the numbers greater than or equal to -3. Well, I got to find -3 first. I just kind of place it, -3 somewhere over here, -3. And now this one has to be colored in. So I'm going to put colored in dot. And the number's greater than -3. Well, the greater numbers, the values increase going to the right. So anything there, and any positive number as well, will be greater than -3. So that's graphing in a nutshell. Solving the inequalities. So this is where it's a little bit new in 7th grade, and there is a trick at the end. But at the beginning, there's no tricks. Super easy. If you're going to solve for x, so some number plus 4 is less than 7. So you're topped out at 7. Well, you would solve it just like an equation. We would subtract 4, and you could do this from both sides. And so this is 0, so x is less than 3. And by the way, for my students, I have not been showing them this balanced equation approach. I've just been showing them, well, if you add 4 to the left, it would be the same as subtracting 4 on the right. So x would still be less than 7 minus 4. So that means x is going to be less than 3. And we get the same answer doing it both ways. So this is it. And you absolutely must have this entire statement right here. Students will often think, well, I'll just write 3 as my answer. But 3 actually is not the answer. Think about this for a moment. 3 is not the answer. Because if I put 3 in for x, 3 plus 4 is equal to 7. 3 plus 4 is not less than 7, 3 plus 4 is the same as 7. So actually, that's why you have to put the entire statement. All the numbers smaller than 3, because 3 plus 4 is exactly 7. So this has to be something smaller than 3. And if you have something smaller than 3 plus 4, that would be something smaller than 7. So then if I'm going to graph this, I'll say zero's over here, 3 would be over here, and the numbers smaller than 3 would go like that. So this is the entire answer. You absolutely must have that, all of it. And then this would be the graph for this solution inequality. And I'll move over to this one here. I would, I think I'm going to put this in blue. So I would subtract 4. Okay, that's the balanced equation approach. And x is going to be less than or equal to, and that's negative 11. And let me compare this real quick to what I've been showing my students. So to rewrite this inequality would be x is less than or equal to negative 7 minus 4, which is what I wrote just before. So that means x is less than or equal to negative 11. And if I graph this, this would be what? 0 would be here, and negative 11 is somewhere to the left hand of that, and it's colored because it's less than or equal to, and the number's less than, so I'm looking at this, the number's less than or equal to negative 11 would go into that direction, because the less numbers are to the left of that graphed dotted number. Okay, this is where things get a little bit interesting. I'm going to solve this one, and pretty easy. All I need to do is, if that's 3 times x is less than 12, then I would divide by 3. And these cancel, and x is less than 4. Okay, that's pretty easy right there. So what this means is, any number smaller than 4 will fit in our inequality. And think of it. What's a number smaller than 4? A number smaller than 4 is 2, right? 2. So if I put 2, 3 times 2 is 6, which is less than 12. Okay, that works. But if I pick something that's bigger than 4, like 5, 5 doesn't work in this. 5 is not smaller than 4, but I'll plug it in anyway. 3 times 5 is 15, and 15 is not less than 12. That doesn't work. Let's go over to this one. So to this one, we have, I would divide by 3, and x is less than or equal to negative 12 divided by 3 is negative 4. And that's the solution. So this entire thing needs to be written down. Because while negative 4 is an answer for this, it's not the only answer. There are many other answers. That's why x has to be small. Anything that's smaller than or equal to negative 4 will work in here, not just negative 4. So you have to account for that. Okay. Here is the tricky one. If I were to divide, now this is negative 3 times x. Yeah. And so the inverse of multiplication is division. So I will divide by negative 3. And by the way, I showed my students this method. If you have negative 3, x is less than 12, then x has to be 12 divided by negative 3. I just made a little mistake right there. I just noticed that I did not place the inequality. It works very similarly, but there is an important difference. So this is what I showed my students, and x would then be less than negative 4. But there's a problem at this point. See, so if I did this here, these would cancel, and x is less than negative 4. And you think everything's fine, but it's not. because if I look at my original inequality, negative 3x is less than 12. And how about I pick a number? A number that's smaller than negative 4, like negative 5, right? Negative 5 is smaller. So I'll plug in negative 5, negative 5 in for x, and let's see what happens. Negative 3 times negative 5, that's positive 15. Is that less than 12? And that's a no. That didn't work. So my solution didn't work. And that's because I have to do this very simple little thing of switching the direction of the inequality. Oops. Right here. Right here. So when you divide by a negative, you have to do this very important thing. You have to switch right there. So in green, notice what happened here. It was open to the right, and now it's open to the left. See, so I did that here, and since it's the same problem, I just did the same thing. Now, let's see how that changes things. That is now, I'm going to erase this here. And what we have is, we have, well, what is a number greater than negative 4? Well, isn't 0 greater than negative 4? That's pretty easy. That's very nice. So I'll use that. In my original inequality, it's negative 3x is less than 12. I grabbed it from the very top right there. And since I say that 0 is greater than negative 4, I'm going to plug in that. Negative 3 times 0 is less than 12. And negative 3 times 0 is 0, which is less than 12. And yeah, that checks. So that means that this is my solution. And so the anytime, notice, and this is a big deal right here. When you are multiplying by a positive, you don't have to switch the inequality right there. When see, I divided by a so here, if you're multiplying by a positive here, then you use division. And I divided by a positive 3. Here, I had a negative 12, but I still divided by a positive 3, and I did not switch the direction of the inequality right there. And then here, I had in my original inequality, I had a positive here, but I had a negative coefficient. I divided by that negative 3, and that's when I had to switch the direction of the inequality. So if you divide by a negative, you have to switch it. See here, I divided by a positive there. So that is the major lesson. And I hope this has been helpful for you. I hope you learned something, and see you in class.